Welcome to my channel, where I talk about DevOps, machine learning, and anything cloud and OpenShift, mainly using IBM tools because, well, firstly, I work for IBM, and secondly, because IBM tools are a lot more amazing than you think. After recording and editing all of this, I realized that this video is really lacking an introduction and motivation. So why do we even do this? Why is this important? What is AI governance? AI governance it's not a tool. It's a framework. It's an approach. It's a mindset, and it concerns itself with all aspects of using AI in an organization. So one part is performance. It's model drift. Is can I even solve my business problems with this model? But the other part that's a lot more critical is bias and fairness. In the past, there have been a few instances where the fairness of an AI model turned out to be a real problem. I will show some links here. You can look them up yourself. And back then, it all ended with, well, what do you call it, a slap on the wrist for the companies. But, well, rightly so, regulators have picked up on those problems, and regulations are becoming a lot more strict. So when you watch this video sometime in the future, it might be a real risk of getting sued for a model that discriminates against some minority. And that's not a trivial task to solve. And well, this is why I'm doing this video, to show you that there are tools that it can help you with this. So let's jump back to the video. Today I will be showing you the first half of an AI governance use case. We'll be using a lot of different tools. First thing will be AutoAI to create a really good model for use cases about car insurances and the outcome of car insurance claims. This is a low-code way to, actually no-code way to create really good models. And then be using Watson Studio to modify this model. We can actually look into the code and change the code as we want. And we'll be creating an AI fact sheet out of it, which will be tracked in Watson Knowledge Catalog, which is a really great tool to track models in the whole organization. I mean, it's not just about the project. Projects are nice and small and easy to keep track of, but if you're a big organization, you want to keep track of all the models that you have. That's why we're going to be using Watson Knowledge Catalog. And lastly, we'll be deploying the model with Watson Machine Learning. And well, that will be the half of the use case that we'll be looking at this video. And in the next video, we will take a look at a really awesome product, which is called Watson OpenScale, which can be used to monitor your model for fairness and for drift and all those things that, well, break a machine learning use case in the long run. So stay tuned. Let's jump right in. First things first, what are we even going to do? We will be working with a data set, pretty popular from Kaggle, car insurance data set. It's about a car insurance claim, like you have an accident and you file that claim with your car insurance. And this is about how often it was approved and well, not approved. And the scenario is that I'm a developer for one of those car insurance companies, and we want to build a system that monitors our insurance claim for irregularities for two reasons. First is we want to improve customer satisfaction. We want to find cases where a customer maybe should have gotten money and didn't. And on the other side, we want to detect cases that are kind of suspicious that we might want to look into because they might be fraudulent. And well, my boss told me, oh, you are the machine learning person. It's your honor to build a demonstration on how to do this properly. And well, this is the basic concept that we will be using. All the work that we will be doing will be in Cloud Pack for Data. If you're not familiar with Cloud Pack for Data, I have other videos. I will link them here that you can check out. By now, I'm assuming that you kind of know the basics, but I think I've explained most things on the way. So I've already created a project for us. And this is, well, it's called Watson Studio. It's kind of the backbone of everything you do in Cloud Pack for Data. And well, now it's time to create a machine learning model. And how do you do this? Well, you can take all your machine learning knowledge and, well, just start coding. You can watch some YouTube videos on how to do a good binary classification model. But, well, this takes time and you also need quite a lot of knowledge to do it. And, well, there's an easier way to do it. Let's create an asset. Let's create an AutoAI asset, actually. Right here. And well, let's call it AI governance AutoAI, for example, we need to associate it with a machine learning service instance. I haven't done this for this project. It needs to be done for every project. It's pretty simple. What's a machine learning service? It's pretty much what provides the compute that is necessary. That's one I already created. Let's use that one. Need to reload the page. There it is. Don't need a description, don't need any text. That's good enough. There we go. Here we are in AutoAI. I'm gonna keep this kind of short. I'll probably make another video where I go into all the details. But this is where we add our data source. So let's just look for our CSV file. One important thing to point out here, I've split the dataset into a train test dataset, which is what you're probably familiar with if you ever done any machine learning. But additionally, I created a so-called holdout dataset, which we will be using in the second part of this series, where we do the monitoring of the model. So for now, you'll be using the train test dataset. Drag and drop. Time series forecast. Nope, this is not a time series forecast. And well, let's actually explore this dataset a little bit. It's a really nice feature. You can preview the data, which gives you really nice histograms of what is actually happening. Yeah, I've got ID, well, it doesn't matter. Age, gender, race. So yeah, there is a lot of room for discrimination here. So good thing we've got Watson OpenScale to monitor this. There'll probably be some issues. Got income, credit score, vehicle owner, a lot of different things. And here at the end, we've got outcome. This is the main thing that we care about. We want to take all those features and predict the outcome. And then we can run this model against any new cases, and we can see if it differs from what we expected, and that could be a positive or negative outlier. Okay, so outcome is what we care about. And let's just choose this here. Wait on there, outcome. And it's a binary classification. So it's just two options, approved, not approved, 0 or 1. And yeah, that's actually fine. Let's just run this experiment. This will take some time. I will probably fast forward this. Just 2 minutes later, we're done. Hardly enough time for a coffee. Okay, what we got? We got a wide range of different algorithms that were tried, and different hyperparameters, different features were engineered for those algorithms. And well, the best one is a snap random forest classifier. Oh, who would have known? Again, I'm going to make a video going into great detail here, but now we're just going to use it. And there are two options of doing this. We can just save the finished model, which is the easier way to do it. But I want to show you that you can actually work with that model, and you've got all the flexibility you could want. Like even it's just as flexible as you would have if you had created it yourself. So let's save this notebook. We're back in our project view. We've got the AutoAI experience we did, we got the data set, and now we've got a notebook here, AI Governance AutoAI notebook. Let's check this out. And there we have all the code that we need to run this very model. Here we've got all the hyperparameters, everything. It's a bit, I mean, if I would have written it, it would look a little different. It might be a bit cryptic at some points, but you can obviously change all the parameters you want. You can manipulate this. You can do whatever you want with it. It's stored as a pipeline, and well, it's all the code you need at the end. You do a test prediction with it. That's pretty amazing. What are we doing now? We want to embed all this into a AI governance workflow. So we need to add some code pretty much at the beginning and the end for tracking and deployment. Now, it's not particularly hard, but well, like they do in TV cooking shows, I prepared something here so we don't have to do it all here on camera. I have this code in my public GitHub repository. I'm going to add the link in the description. And a very nice feature of Cloudpeak for Data is we can very easily clone a notebook straight from GitHub. Let's do that. From URL, Just paste the URL here, and we're gonna use the same name and create. There are 3 things we need to change in this notebook. They were left out for obvious security reasons. I don't want to have my API key and my credentials in GitHub. The API key I can get straight out of my IBM Cloud UI. I need to create a new one here. I've already got mine. Just paste this in here. Now we need to add the project token, which is really simple. If you do it for the first time, you have to create it in the project. It's just a few clicks. Project, manage access control, access tokens, new access token. Just call it token, and just give it editor access. And let's do this again. Insert project token. There we go. Insert it on the very top. And a third thing that's specific here for our AutoAI use case is that we need to add this part here. I just jumped back into the created in the notebook that was auto-created by AutoAI. And we just take this whole part, which is the reference to the training data and where the model was stored. And let's paste this in here. There we go. Now everything should work. I'm going to run this notebook from top to bottom, just real quick. Not going to go into any details. And now we create the pipeline. So in the context of AutoAI, if there's talk about a pipeline, what is meant is a scikit-learn pipeline, which is a great concept. Well, not invented by IBM AutoAI, but by the great people at Scikit-learn. And this enables you to take all your pre-processing and all your training parameters and all the training logic and handle it as one object, and also save it as one object. Successfully saved the model, and well, let's check it out. We can use this trail here to navigate. Let's go back to our project, and here we see, yeah, awesome, insurance claim output prediction. Our model appeared here. So if we click on it, we can see our AI fact sheet. There is a lot of stuff here. If you've been mainly working on your own or in smaller projects till now, you might ask yourself, what do I even need all this stuff for? Isn't this like way too much? And yeah, if you're a single contributor or a small team, yeah, this is way too much. But this is meant for organizations that are serious about what they do. And if you are working in a team, multiple people working on the same data, working on the same models, you need to deploy them to production, and you need to know what the models that you have deployed are, the characteristics of those models. Particularly if you're working in a highly regulated industry, which insurance industry is, you need to have this. It's mandatory to have information like that. You might be asked by regulators what models you are using right now, why you're using it, what were the features it was trained on, what's the data it was trained on. And if there's something wrong, if somebody files, worst case, a lawsuit against you, you better have all of this information to justify what you have done and why you're doing it. Additionally, there are some things that are very relevant for operations. If you look at this input schema, you can imagine this can be really helpful if you deploy this model in production. Maybe somebody created a new model where they've thrown out, for example, age for whatever reason, and all of a sudden the interface of your model changed, and if you don't have a way to properly document this can get you into a lot of trouble with your operations team and might break a lot of your services. So we have created our model. We tested it. It works. We have documented it with an AI fact sheet. So I guess we're done, right? Well, not quite. What we are doing here is data science work. Those projects, this project that we've been working on, that's data scientist country. Data scientists work here, they create stuff, they delete stuff. Some point they move on to other projects, and this area gets deserted, and in a few months nobody has an overview of what is happening here. We need something bigger. We need something on organization level to document the models that make it from data scientist country into operations country. And that's what Watson catalogs have been created for. Let's create one of those catalogs. I could spend a lot of time trying to explain what they are. They are very powerful constructs, but I guess we just see it in practice. Let's create a catalog. And remember, this is on an organizational level. This is not for the small project we're doing right now, but this is supposed to outlive our project by a far margin. So a good name could, for example, be, I actually already came up with one, assuming the name of our company is Golden Insurance Corp. It's a kind of a cliche name, I guess, but well, then Golden Insurance Corp Data AI Department Catalog. That could be a feasible scope when we're talking on the department level here. Enforced data protection, don't worry about it for now. Okay, let's create this catalog. Here we have our empty catalog. Those catalogs can do a lot of different things. For example, if you want to make data available to some department, for example, the data AI department, and you want them to not have access to some sensitive fields in this database. For example, you have customer data, and you don't want the data scientists from the data AI department to have access to the payment information of those customers. Then you can use a catalog for that to set up rules and to disguise those fields that you marked as sensitive. But that's not what we are using the catalog for today. We are using it to store, to catalog our models. Well, I have to admit that step is a bit unintuitive, but well, I guess that's what you're watching this video for, so I will tell you how to do it. We want to create a model inventory in this catalog. The way you do this is you create a model inventory and then you assign it to the data catalog. And well, actually, you don't create a model inventory, you create a model use case. So we need to name this use case, and here we have to be a bit more specific because, well, we want people to understand in the future what this use case is, what we're doing here. And well, we are doing car insurance outcome prediction. So I guess that's a good name for a model use case. Save this. Here's our model use case. Pretty empty at this point. Let's add our model that we just created to this model use case. Now, jump back to our project and click on our model, insurance claim output prediction. And we can track this model now. And this is, yeah, here's our use case. Awesome. Track. Now we have our model nicely and tidily tracked in our model inventory that is assigned to a knowledge catalog. So pretty cool. If we check out this model inventory now, takes a moment, we can see that it tracks this model now. And if we go to asset, we can actually see, well, I guess that's a deployment pipeline that we see here. Now, at this point, we're in the development stage. This is when you first add a model to a model use case. It always ends up in the development, the develop stage. We feel pretty confident about the model that we created. So it's time to deploy that model. To do that, we jump back into our project, into our, well, this is our AI fact sheet here. And there's a big button that says promote to deployment space. Deployment spaces are pretty much compute instances, managed compute instances that you can use to deploy the model and also the data and other scripts that you used to create this model all together. We're going to do the most simple version we can do, which is just deploy the naked model on there. So we create a new deployment space. Again, we want a good name for it. We call it car insurance outcome prediction test space. Okay. Comes a bit long at some point. You need to select an existing machine learning service. It's called Watson Machine Learning. Pretty uncreative name for the machine learning service we created. And well, that's all we need. Create. The deployment space was created. Now we promote the model. It was successfully promoted. Now we can check out this deployment space that we created. If we look into the assets, we find our model. And here we can do the actual deployment. What we need is a deployment name. And obviously it's an online deployment, so it just runs for every time it's called, it runs once. It doesn't collect data and process them as a batch. So we call it test deployment 01. We should increment that because we might want to have multiple of those. Let's create. And it was barely a minute and it is already deployed. Now, if we look into our catalog, then we should be able to see this. Here it is. There is our deployment. We are just getting started here in this AI governance lifecycle, but already we've developed the model. We said we're happy with it and promoted it to a test space, and we deployed that model in the test space. So we're already dealing with 3 different artifacts. So if you ask yourself, what do we even need this model use case Watson catalog thing for? Maybe it starts making sense now. And this is only the beginning. Thanks for watching. That's it so far. I hope you learned something in this video. And well, some final words maybe. You've probably seen a lot of machine learning videos at this point and probably done plenty machine learning yourself, and you might be used to it being all sexy and flashy and awesome and just import this library, import this here, and there's your stable diffusion image generation awesomeness. That's great. I personally love doing this stuff as well. But the reality of machine learning that actually people make money with, is this kind of stuff. You have tabular data, you create a fairly simple model with it, and you use this in production. And this is super important, super critical, and this is where organizations actually spend money and where they also fail if they don't do it properly. So bear with me. The next video will be a lot more visual. And remember, if you want to be successful in machine learning, that kind of stuff is super important to know. So again, thanks for watching. See you next time.